Hello everybody and welcome to today's video. We've already learned how to factorize quadratic trinomials of the form x squared plus bx plus c. But notice that the number in front of x squared in this form is always 1. So what if we have a number other than 1? Right? What if we have, let's say, a number, I don't know, 3, 4, 5, doesn't matter. How would we be able to factorize this? So let me write down the more general form of a quadratic trinomial, which begins with ax squared. And a could, be any number. It doesn't have to be 1. So recall that when a is equal to 1, in order to factorize this, all we got to do is find two numbers that have a sum of b, which is basically the number that is in front of the x, and a product. So they have a sum of b and also a product of c, which is basically the number that is by itself at the end, so c. Okay, so that's when a is equal to 1. We have to find two numbers that meet those requirements. Okay, what happens when a is not equal to 1? Is there a, tried to draw a line there. Okay, that's a little bit better. So what happens when a is not equal to 1? How do the requirements change? So a is not equal to 1. Okay, and note that a can never be equal to 0, because if it is 0, then this entire term would be 0, and we no longer have a quadratic trinomial, right? We no longer have a quadratic expression because the x squared goes away, and we no longer have a trinomial because we only have two terms, which means it's a binomial. All right, so I just wanted to clarify that. So a cannot be equal to 0. Okay, so what happens when a is not equal to 1? What are we trying to do? Well, we're still trying to find two numbers that have a certain sum and also a certain product. All right, so the two numbers that we're looking for when a is not equal to 1 must have a sum of b, which is exactly the same as when a is equal to 1. Okay, but they're going to have a product of not c, but a times c. Okay, so that's the only slight modification here. And that's it. The only difference is that the product of those two numbers we're looking for is different. And you can also say they're not different, because here we're also finding a times c. Right here, the product we also want two numbers that multiply to a times c. It's just that a is equal to 1, and so a times c is just equal to c. So we don't need to perform that operation of a times c. Okay? But in this case, a is not equal to 1, and so a times c is not equal to c. All right? So after we find those two numbers that meet those requirements, then we're going to split the middle term into the two numbers that we found. Okay? And then we're going to factorize by grouping. So let's actually illustrate with an example just to make it a little bit easier. So let me just remove this. And let's factorize 3x squared plus 10x, or actually not 10x, plus 17x plus 10. Okay, so let me write down what the a, b, and c here are. So a is equal to 3, b is equal to 17. Right? Remember, in the general form, this was a, right? A was the number in front of x squared. So a is equal to 3 in this case. B was the number in front of x, and in this case it's 17. And c was the number that is by itself, which is just equal to 10. Okay? So this is the a, this is the b, this is c. So now we're going to look for two numbers that add up to b, that have a sum of b. So sum of b, and b is equal to 17. And also two numbers that have a sum of 17 and have a product of a times c. So product of a times c. Now what is a? A is 3. And what is c? C is 10. So a times c is 3 times 10, which is just equal to 30. All right, so we're looking for two numbers that add up to 17 and multiply to 30. Now we can use the Potion law method, which we covered in a previous video. I can put the link to it if you guys would like to check it out. But in this case, I think it's a little bit faster to guess and check. Okay, notice that the product is positive, which means that the two numbers that we're looking for must share the same sign. Right? They're either both positive or both negative. Now, which one is it? Well, they add up to a positive sum. And so this immediately tells us they have to be positive, because if we have two negatives, they're going to have a negative sum. Okay, so let's list the positive factors of 30. What do we multiply to get 30? Well, 1 times 30 is an option. 2 times 15. Okay. 3 times 10. 5 times 6. And I think that's it. Okay, so let's look at each of these factors, and let's see which factors add up to 17. Okay, so 1 times 30, 1 and 30 add up to 31, so we don't want that. 5 and 6 add up to 11, we want 17, so we don't want that. 2 and 15 add up to 17, which is perfect. Okay, they multiply to 30 and also add up to 17. 3 and 10, they add up to 13, so we're not looking for that. Oops. Okay, so that is what we want. Those are the two numbers that we're looking for. All right, so now, after we found those two numbers, I'm going to make some space to split the middle term. Okay, so we have 3x squared plus, notice, remember the numbers are 15 and 2, so we're going to split the 17, or the 17x, into 15x plus 2x. All right, those are the two numbers that we found. And then we're going to keep the 10 as it is, and that's it. We only do the splitting to the middle term, right? That's why it's called splitting the middle term. Okay, so now we're going to factorize by grouping. So I'm going to group those two terms together and those two terms together. And I'm going to factorize each group separately. Okay, so here I can pull out a 3x because they both have 3x in them. Okay, now 3x times what gives me 3x squared? Just x. Now we have positive. 3x times what gives me 15x? Just 5. Okay, and then we have plus. And here we could pull out a 2. Okay, after we pull out the 2, what remains is x plus, and 2 times what gives me 10? Just 5. Okay, so notice now we have two terms. One term is 3x times the quantity x plus 5. That's our first term. And our second term is 2 times the quantity x plus 5. And notice they both have x plus 5 in them. So we could pull out the x plus 5. So let's do that here. We pull it out, and we open up a new set of brackets to put what remains inside. And I'm going to switch colors here. And I'm going to highlight what remains. And what remains is 3x plus 2. And I can just write that down here. 3x plus 2. Okay, and I just noticed that this is a C. Sorry about that. Okay, so that's it. We have factorized this expression. All right, so all we got to do is find two numbers that add up to b, the number in front of x, and multiply to a times c. Okay, and after we find those two numbers, we're going to split the middle term into those numbers, and we're going to factorize by grouping. Okay, so let's actually do one more example. Let's factorize 6x squared minus 11x minus 10. All right, so let's list out what a, b, and c are here. So a is equal to 6, b is equal to negative 11, and c is equal to negative 10. Okay, so we're looking for two numbers that add up to b, which is negative 11, and multiply to a times c, which is 6 times negative 10. which is equal to negative 60. All right, so two numbers that add up to negative 11 and multiplied at negative 60. Now the product is negative here, which tells us that one number, which tells us that the numbers we're looking for have a different sign. Okay, because again, if they have the same sign, then the product will be positive. Now, should I consider all the factors of negative 60? Well, maybe there's another hint here that could, allow me to limit the factors. Look at the sum. The sum is negative, meaning that the size of the negative number, okay, because again, we know that we have a negative number and a positive number that will fulfill those requirements here. The negative number is larger in size than the positive number, okay, because if the positive number was bigger in size, then the sum would be positive, right? And if the negative number is bigger in size, then the sum would be negative. Okay, so we only consider the factors of negative 60 where the negative number is larger than the positive number. All right, so I hope that made sense. So we're not going to consider, for instance, 1 or negative 1 times 60. Why? Because what number is larger in size? Obviously 60, right? So because the positive number is larger in size, that means we're going to get a positive result if we add them up. Okay, so we need the negative number to be larger in size. So what we can consider instead is negative 60 times 1. Okay, because now the negative number is larger in size, and so they're going to add up to a negative number. Okay, so what is another consideration? We can consider negative 30 times 2, negative 20 times 3 is another possibility, a negative 15 times 4, negative 12 times 5, and I think negative 10 times 6. These are all the factors of negative 60 where the negative number is larger. Okay, and I think that's it. I'm not entirely sure, but I believe that's it. So which one of these sets has numbers that add up to negative 11? Well, negative 60 plus 1 is not it. Negative 15 plus 4 is perfect. Those two numbers add up to negative 11. So that is what I'm looking for here. So I could consider all the other sets, but I know that they won't add up to negative 11. Okay? So I'm just going to cancel them. So these are the two numbers I'm looking for. All right, so let's make up some space. Oops, sorry about that. All right, so our two numbers are negative 15 and 4. So we're going to split the negative 11x into negative 15x and 4x. All right, so negative 15x plus 4x, and then we have minus 10. Okay, so now we're going to factorize by grouping. I'm going to group those two terms together and those two terms together. All right, so let's factorize each group. So here we can pull out a 3x. They both have 3x in them, so 3x. 3x times what gives me 6x squared? Just 2x. Okay, we have a minus, so I'm going to keep it. 3x times what gives me 15x? Just 5. And we're done with that group. All right, so for our second group over here, we can pull out a 2. They both terms have 2 in them, so plus 2. And we open up a new set of brackets, and we keep what remains aside. 2 times what gives me 4x, just 2x. There's a minus sign, so I'm going to keep it. 2 times what gives me 10, just 5. Okay, and notice again we have two terms, both of which have 2x minus 5. So we can pull that out. Okay, so 2x minus 5. And I'm going to switch colors here, so what remains is 3x plus 2. Okay, so we're going to keep that here. And we're done. That's it. Okay, so I hope that made sense. And I wanted to show you a situation where this entire process is actually Not necessary, but it's only a situation where you can remove a common factor. Okay, so let me actually give you one more example. So it's going to be very quick. So let's just remove this. Oh God. All right, let's factorize 3x squared plus 6x minus 72. Now, do we have to go through all that process of finding two numbers and splitting the middle term and all that good stuff? Well, in this case, we don't actually have to do that. Okay, because in this case, we can actually pull out a common factor, and that is the first thing you should try to look for whenever you're factorizing. It doesn't matter what you're factorizing. Okay, try to look for a common factor that you could pull out. And in this case, is there a common factor between the terms that we have? And the answer to that question is yes. 3 is a factor of all terms, right? So we could pull out a 3. Okay, 3 times what gives me 3x squared? X squared. Okay, 3 times what gives me 6x? It's just positive 2x. And there's a minus. 3 times what gives me 72? Just 24. Okay, and how did I immediately know that there is a factor of 3 here? How did I know that 72 has a factor of 3? Well, there's a very, very nice trick you can use whenever you want to, whenever you, what is the word I'm looking for? Whenever you're trying to see if a number, well, that's not the best word, I guess, but whenever you try to see if a number has a factor of 3, you can just add up its digits. So 7 plus 2, in this case, that's the digits. Those are the digits of 72. So you add the digits and then you divide by 3. If you get something that is a whole number or not a fraction, then it's divisible by 3. Okay, so 9 over 3 is just equal to 3, and that's a whole number, right? It's good. So it's divisible by 3. Okay, so that is a trick for knowing if a number has a factor of 3. All right, so now we get this, and we know how to factorize this. All right, all we got to do is open up 2 sets of brackets. Okay, we keep an x in both to get our x squared. And now we try to find two numbers that add up to 2 and multiply to negative 24. And those numbers happen to be 6 and negative 4. All right, so positive 6 and negative 4. And we're done. All right, so the purpose of this example is to show you that we don't have to use the splitting the term method all the time, because in some cases we can actually factor out some stuff and be left with this form of a quadratic trinomial, which we know how to factorize easily. Okay, so that's it, guys. I hope you enjoyed the video. I hope that made sense. And as always, if you have any questions, please let me know in the comment section below. And that's it. I'll see you next time.